Hello, welcome back to the podcast. I'm Isabella Pham. If you're new here, what's up? How's it going? And if you're joining us again, what's up? How's it going? It's really nice to see you again. This is the Science for Everyone podcast, a podcast where we make modern science accessible to anyone who is curious. Today, we're going to address a question asked by science_curious_netizen137 who asked, I recently saw a headline about the oceans warming up. How do we know that they are warming? Very good question. At first, it seems like the answer might be quite obvious. Don't we just measure the temperature of the oceans every so often and record the data? Well, no. It's actually more complicated than that. Before we determine whether the oceans are warming, we need to figure out how are we measuring the temperature of the oceans. There are 6 different ways scientists measure the temperature of oceans. Ships, moored buoys, XBTs, satellites, cargo floats, and mammals? We'll talk about mammals later. Let's start from the very beginning. Since the 1800s, buckets on ships were tied to ropes and lowered to certain depths. The buckets were then pulled up and the water temperature was measured by a thermometer on board. This method of measuring the temperature of the ocean is problematic, especially when it comes to accuracy. Different depths of water have different temperatures. Additionally, the air temperature is different to the water temperature. So, the water in the bucket will undergo thermal energy transfers as it travels back to the boat. The measured temperatures can be both warmer and colder than the actual temperature, so adjustments aren't necessary to create a consistent time series. Furthermore, it doesn't sample everywhere because there are not many shipping routes, especially in the southern hemisphere. However, there have been some improvements to this method, increasing its accuracy. The buckets, which were initially uninsulated and wooden, have improved to be insulated with canvas, and they have moved from using mercury to electronic thermometers. The benefits of using ships to collect ocean temperature data are that it gives us data from the 1800s, when the technology to obtain accurate data was not available. Fast forward more than 100 years later, in 1951, moored buoys that were fixed in the ocean were used to collect data in addition to the temperature using a sensor above water. However, like the ships, there is still limited coverage and was quite expensive. This method is also good for the time series. Not long after the introduction of moored buoys, in 1967 expendable bathymographs, or XBTs, were used. A device with a wire is shot by a scientist on board into the water. As the device sinks, it measures the temperature of the ocean and sends back info onto the ship and data is stored on board. When it sinks to a depth of about 800 meters, the wire is removed. There is still limited coverage with this process, and the devices litter the ocean as they are not retrieved. However, there are repeated lines that are good for the time series, and this method is relatively cheap. Since 1979, scientists have been using satellites to obtain data about the temperature of oceans. There are 2 wavelengths used, infrared and microwaves. Infrared only has 1 to 4 kilometers of resolution, but can't see through clouds, and microwave has 20 to 50 kilometers resolution, but can see through clouds. A combination of both wavelengths is used to get a more accurate picture. Even though satellites allow for a broad coverage of world's oceans, it only measures the sea surface. You know when you go to the beach and you realize as the deeper you go, the colder the water gets? Well, since satellites can only measure the surface level temperature of oceans, this is especially bad for oceans in tropical climates where there is a great disparity between the top surface of the water and deeper water. Also, satellites litter space. In 2000, cargo floats were used to observe temperatures below the surface. They spend 6 to 12 hours floating around the ocean to transmit data to a satellite, and after they've had their fun in the sun, they descend into the deep blues of the ocean at 10 centimeters per second for 6 hours. When they reach a depth of 1,000 meters, they decide to go on a little holiday and drift for 9 days. I'm not sure about you guys, but I sure do need a 9-day holiday. Or any holiday. Anyways, some floats even go down to 2,000 meters below the surface of the water. After they finish their little trip, they hop on a 6-hour ride home to the surface to measure the salinity and temperature. Once they are at the surface, they spend the next 6 to 12 hours posting all about their trip on social media, aka transmitting data, because they couldn't transmit information from underwater as the water is opaque to satellite communications. The main disadvantage with cargo floats is that they cannot collect data where there is a lot of ice, because they are a little sensitive to the cold and ice damages them. Secondly, they are also really expensive and they do litter the ocean. So how do we collect data from the oceans where the ice is? One word: seals! In 2004, scientists started using mammals such as seals to sample data. A small CDT is fixed to a seal's head and collects data as they swim under ice and transmit data when they are out of water. There is a question of ethics of using seals and other mammals to sample data, even though we do have permission to do so. But sometimes the CDTs fall off the seal's head and this can pollute the oceans. When you bring all 6 methods together, you form the Global Ocean Observing System, also known as GOOSE. GOOSE shows us the temperature of the ocean since the 1800s, and when the data is displayed appropriately, scientists have noticed a trend that the temperature of the oceans is indeed getting warmer. I hope that answers your question. Thank you so much for listening to the Science for Everyone podcast. Tune in next time. Bye!